Hey, this is lesson 8.1, the sine law. Today we're going to be actually looking at solving for sides and angles in triangles that are not right triangles. So triangles that do not have a 90-degree angle in it. So the sine law is the first one we're going to look at. This is one of the formulas used to find sides and angles in acute triangles. Acute. That's a C there. These are triangles that have all angles less than 90. So that have all angles less than 90. So no 90-degree angle in there. Don't forget when we used to talk about acute angles, acute angle would be less than 90 degrees. So it makes sense that if all the angles are less than 90, it's called an acute triangle. So to find a missing side, your formula for the sine law is going to look like this. Little a, which is a side, side A, over sine capital A. So the little a is the side, capital A is the angle. So the side over the sine of the angle equals little b over sine b. Again, that's your side over your angle, equals little c over sine c. So if you're finding a missing side, you're going to start with this formula because the side is on top. It's just way easier to solve an equation when your unknown is on top. So that's why you're going to see the sides on top. So what about if we're finding a missing angle? Instead of having the sides on top, we're actually going to flip everything over to have the angles on top. So your formula is exactly the same, except we are flipping all of the ratios so that now the angle is on top. And that's just going to make it easier to solve. So we got sine A over A equals sine B over B equals sine C over C. So this is the sine law. When you use this formula, you actually only use two of the ratios at a time, depending on what you're finding and what information you're given. So you're not going to use all three of these. You're not going to use all three. You're going to end up picking two of them and then solving. So I'll show you what I mean here. We're going to find angle C in triangle ABC. So we're going to be using two ratios to solve this. So we're finding angle C, which if I look at my diagram here, they've actually put a little mark there because this is the angle that I'm finding. And so I need to use the ratios with the C's in it because I want to find angle C. So let's just go ahead and label the sides here. We have capital A, capital B, capital C for our angles. The little letters go directly across. Directly across from big A is little a, that's the side A. Directly across from big B is little b. And directly across from big C is little c. So we've labeled the angles and the sides. Your next step is to look at this triangle and find an opposite pair. And by opposite pair, I mean an angle across from a side length that's given. So I see that I have angle B and I have side B. So we call this an opposite pair. So opposite pair. And in order to use sine law, you have to have an opposite pair in your triangle. Sometimes you're missing an angle and you can find the other one by taking 180 and subtracting the other two, and all of a sudden you'll see that you now have a side angle pair or an opposite pair. But in order to use the sine law, you have to have one of these opposite pairs. So because I have an opposite pair of B's, I know I'm going to be using the B ratio, the one that has the B and the sine B. The other ratio is going to be your unknown. So since I'm trying to find angle C here, I'm going to be using the formula for solving for an angle, which is this one here. And I'm going to be writing down the angle C part first because that's what I want to find. So I'm finding angle C. So the first thing I'm going to write down is sine angle C. Okay, so whatever you're trying to find, that's the first thing you write down. So I'm just going to put start with unknown at the top. Start with unknown at the top. All right, so now I'm going to continue on with the sine law here. I need another ratio. Again, you're going to be using the opposite pair that I've circled here. So I've circled the b's because I have both b's. So I'm going to be using b as my other pair. Sine b over little b. So now that I've set up my ratio, I'm going to sub in what I know. And in order to solve this, I need everything except the big angle C, because that's what I'm trying to find. So let's see what I sub in here. I don't have my big C. However, I do know that little c is 15. And on the other side, big B would be my angle. So my angle is 72. Little b is directly across, so it's 18. So see how I filled in all of the values except for big C. That's what we're trying to solve for. So now we're going to get big C all by itself. Right now it's divided by 15. So I'm going to take that 15 and multiply it over to the other side so we can try to get this C value here. I'm going to take the 15, move it over. And then there's going to be one last step here. Because I'm solving for an angle, it's just like when we were using trig ratios. Anytime you solve for an angle, you're going to have to use that inverse. So anytime you're solving for an angle, you need to use the inverse. So I'm just going to bring this up here. I'm running out of room. Angle C then is going to be the sine inverse of all of this stuff. So here's where you're going to do some practice with your calculator. I want to punch all that in one step, because if you punch it in one step, you're going to get the most accurate answer. So for my calculator, I have a regular forwards calculator. I would be typing in shift C or second function, sorry, sine, shift sine or second function sine, because that gives me my inverse. So that would be your inverse. And then I would be typing in bracket 15 times sine 72 divided by 18 bracket. So I'm just going to try that in my calculator right now. Shift sine bracket 15 times sine 72 divided by 18 bracket. And then you're going to hit equals. So I got to hit equals after that. And when I do that, I actually get 52.4, which don't forget when you're solving for angles, if it doesn't say, we are going to round it to the nearest degree. So try punching that in your calculator to get 52 degrees. If you have a backwards calculator, you're going to do it backwards. I would start off with 72 sine times 15 divided by 18 equals, and then shift sine or second function sine. So again, if you have any calculator issues, let me know. Try that, see if you can get 52 degrees. You can pause the video if you want. I'm going to move on to the next one. Find the length of the equal sides in isosceles A, B, C. So don't forget, when we use sine law, we need to have an opposite pair. So I actually see my opposite pair here, my A's. Oops, that's not very nice here. Okay, there's my opposite pair. And I'm trying to find the length of these two sides here. Again, I'm just going to pause and label these. Across from big A is little a, across from big B would be little b, and across from big C is little c. So in order to find the side length of either C or B, which they're equal, so it doesn't matter which one I choose, I'm going to need these angles in the bottom. So I'm going to need either angle B or angle C. So how do we find that? Well, since I know they're the same, I can take 180 and subtract 40. And that's going to leave me with 140. I know B plus C has to equal 140, and B and C are the same because that's an isosceles. So if I take 140 and split that in half, split that in between the two angles, we actually get 70. So both of those are 70 degrees. Kind of looks like a decimal 70, doesn't it? There we go. Okay, so I have my side angle pair. Now I know that the angle across from my unknown is 70. I'm going to write out my formula here. So don't forget we can either find C or B. So let's find B. And with the sine law, I always start with my unknown. So since I'm finding little b, I'm going to look back up to my formula. I'm finding a missing side. So I would be using the ones with the sides on top. And since I want b, I'm going to start with the b. So b over sine b equals, and here's where I'm going to use my opposite pair. So I circled the a's. So I'm going to be using the pair with the a's. Little a over sine a. So I got my ratio. I'm going to sub in everything I know. I don't know little b, but I do know that big B is 70 and little a is 12. Big A is angle A, so that's 40. And again, I want B all by itself, so I'm going to take that sine 70 and move it across. When you move it, it's going to be multiplied at the top. And this one, we don't have to do the inverse, so this one's a little more straightforward. We're just going to punch that into our calculator. My forwards calculator, I would do 12 times sine 70, you could hit equals, divided by sine 40, hit equals. And you're going to get 17.5 inches. Don't forget, when you're solving for a side, you round to one decimal place. So therefore, side B and C, because it's isosceles, are 17.5 inches. And the third question, example 3, explain why the sine law cannot be used to solve for an angle in this triangle. So don't forget, when we use sine law, we need that side angle pair or an opposite pair. And in this case, we do not have an opposite pair because we don't have any of the angles. So since we're not given any of the angles, since we are not given any angles, we do not have a side angle pair or an opposite pair. And therefore, we cannot use the sine law. Is it still solvable? Yes. You're going to find that with the next lesson. I'll show you how to do that. Okay, so we got some homework here. Again, this is listed in your binder or on the announcement on your main page of our D2L, the questions that I want you to do. 1 to 6, these are a little bit lengthier, so I did say to do A only. That's for all of them. For 1, just do 1A, do 2A, do 3A. If you're finished and you actually want to do some more practice, you can go back and do B. So each one has A and B. However, I'd really like you to just try A so that at least you can try one of every different kind. So try one of every kind. Again, if you want to go back and do part B, you can. Make sure you are checking those answers in the back of the book and emailing me if you have any questions, and we will take this up at our next meeting.